Hey, welcome back to everyone to another video of coordinate geometry. In the previous video, we have understood how to do the translation of axis. Translation is simply shifting the position of origin without rotating the coordinate system. But rotation is we are not changing the position of origin, we are just rotating the axis by some angle. Okay, so if you want to know completely about translation, go through the previous video. After that, if you come to this video, then it will be more helpful for you. Now, let us see what is the actual situation is. Initially, so this is the x and y axis or is old coordinate system, and there is a point here whose coordinates are x comma y. So we already know that the x coordinate is nothing but the perpendicular distance from the y axis to the particular point, and y coordinate is nothing but the perpendicular distance from x-axis to the particular point. Okay, so already I have drawn the old coordinate system and the point is represented here. Now I have shifted the origin by an angle of theta in anti-clockwise direction, let us say. So this is the angle by which the axis, the coordinate system is rotated. Now when the coordinate system is rotated, the point will not change. That's why I wrote here p small x comma small y is equal to p capital X comma capital Y. So the coordinates will not change, but we need to know what is the relation between these two coordinates, which is capital X and small x and capital Y and small y. Okay, now from the figure, if you observe clearly, let me find first the relation between x coordinates of old system and new system. Okay, now from the diagram you can observe that uh, from here to here, so this point to this point, the distance is capital X. Is it right or not? Now that capital X is making an angle of theta here. So how can I write the relation between them? Now from the triangle, let us say this is point O, this is point A, and consider this point as point B. Now from triangle OAB, let me write, okay, uh, cos theta, let us suppose cos theta is equal to adjacent side by hypotenuse. Is it right or not? So what is the adjacent side? Adjacent side is the sum of these two sides, small x and small h. It is the sum of two terms. Therefore, it is OB. Okay, x small x plus h by, and what is the hypotenuse? Hypotenuse value is capital X. From the diagram you can clearly observe that. So small x plus h by capital X is equal to cos theta. Therefore I can write small x plus h is equal to x cos theta, and small x is equal to capital X cos theta minus h. Okay, we want to find that particular h value in terms of capital X or capital Y. Suppose now if you see the triangle, one more triangle, as I want h, I am checking another triangle here. Let me consider this point as a C. So from the triangle C, this is the new triangle. So this is the new triangle PCA. Okay, so let me write here from, oh sorry, from triangle PCA. What actually I need is this horizontal distance between these two points, this point and this point. It is h actually. It is same in the triangle also. Therefore I want to find sine theta, so which is opposite side by hypotenuse. So h sine theta is equal to h by hypotenuse is this one from here to here. This is the hypotenuse, okay? And from the figure you can observe that hypotenuse is capital Y, okay? Okay, now sine theta is equal to h by capital Y. From this I can write h is equal to y sine theta. Okay, now let me just move it a little bit further. Okay, now substituting this h value in this particular equation, you will get small x is equal to capital X cos theta minus capital Y sine theta. Okay, so this is the relation between the old coordinates and the new coordinates. So from this equation, if you know capital X and capital Y and the angle by which the axis is rotated, you can easily find small x. Okay, let us find what is Y. Okay, now from the diagram you can observe clearly uh, y is the sum of two quantities. Okay, so let me draw a dotted line and a straight line. So this is a straight line which I have drawn just now. Now it is cap small y. Okay, so small y from the diagram is summation of this point is P and this point is C and this point is, let us consider this point as D. Okay, so y is equal to PC plus CD. Okay, now what is CD? CD is same as AB. CD is same as AB. Now from the triangle OAB, right? From the triangle OAB, sine theta is equal to AB by hypotenuse. Hypotenuse is a capital X. Therefore, AB is equal to X sine theta. Now I got AB. If I got AB, it indicates it is also same as CD. Therefore, CD is equal to AB is equal to X sine theta. Okay. Now, I want to find what is PC, right? If I want to find what is PC from the triangle PCA, again I'm using triangle PCA. Now I just want to find cos theta. Cos theta is adjacent side by hypotenuse. Here adjacent side is PC by hypotenuse is capital Y from the diagram. From this you can write PC is equal to, right, y cos theta. So y cos theta, it is also same as K from the given figure. You can easily observe that. Now I got PC value and I got CD value. Therefore y is equal to PC plus CD. So small y is equal to capital Y cos theta plus x sine theta. So x sine theta I am writing first and then I am writing capital Y cos theta. Okay, so this is the equation which helps us to find y coordinate of the old system. If you know xy coordinates of new system and the angle by which the axis or the coordinate system is rotated. Okay, now let us do a small mathematics here to derive two more relations. Means if you know capital X, capital Y and theta, you can easily find small x value as well as small y value. But if you know small x and small y values, if you want to know capital X and capital Y values, we can do a simple modification for these two equations. So let me write these two equations in matrix form. So small x, small y. This is a column matrix which contains two rows and one column. And I'm considering this as a 2 by 2 matrix. And first term as cos theta, second term as minus sine theta, third term as sine theta, fourth term as cos theta, multiplied with one more 2 by 1 matrix which is capital X and capital Y. You can write these two equations in matrix form like this. Now if I want capital X and capital Y from this matrix equation, you can send this matrix, which matrix? So this matrix you can send it to numerator so that you can find capital X and capital Y values. When you are sending this matrix to other side, you need to take the inverse of that matrix, right? Therefore, what I am trying to do is I am just taking the inverse cos theta minus sin theta into cos theta inverse multiplied with small x and small y. Okay, so let me do the remaining calculation in the next page. Now it is a 2 by 2 matrix, and if you want to find the inverse of a 2 by 2 matrix, it is so adjoint of that matrix divided with the determinant of the matrix. Okay, so first I'm writing the determinant 1 divided by AD minus BC. So these two are AD and these two are BCs. So AD minus BC means cos square theta minus of minus sine square theta, and adjoint is D minus B minus C and A. So what is D? So cos theta, I'm just writing as it is. Minus B means sine theta. Previously you have minus sine theta, now it becomes sine theta, and it becomes minus sine theta, and you have cos theta as it is in this equation multiplied with the small x and small y matrix. Now it is equal to cos square theta minus of minus plus sine square theta, which is equal to 1. So I am not going to write the denominator here. I am just writing the matrix equation. Capital X capital Y is equal to cos theta sine theta minus sine theta cos theta multiplied with small x small y. Okay, therefore from this matrix equation we'll get two more equations, which are capital X is equal to x cos theta, small x here, x cos theta plus y sin theta. Similarly, capital Y is equal to minus x sin theta plus y cos theta. Okay, so in this way you can find the relation between the two coordinates in old system or in a new coordinate system when it is rotated by an angle theta. If you know the angle and if you know the coordinates, you can find the other two coordinates. Okay,